So we're talking about J.J. Thomson. Everybody in his time period, all the scientists, like all of them, y'all with me here? They were all studying this thing called the cathode ray tube, which is abbreviated CRT, if you care. Duh, right? But more importantly, what is it? You've seen these before, I'm sure of it. Yeah, and it's not a catheter. That's a good guess. Has anybody ever heard a TV ever called a tube? Like, have you ever heard anybody say something like, y'all sit in front of the tube? Yeah. You heard that expression? Yeah. Do you know those old TVs, the ones that like stick out way far behind and they weigh a ton and a half?
Oh, yeah. Oh, yeah. I know. Bubble TVs?
I don't know what a bubble TV is. Oh, yeah, like the screen is round. Yeah. The reason they call them that is because they're made of cathode ray tubes. And so that's where that's why we call them the tube. That's where initially the name all came from. Okay? So we're going to talk about what is a cathode ray tube, but suffice it to say at this moment at least that a cathode ray tube, it has some very toxic chemicals in it, some lead, some mercury, stuff like that. And for that reason, it's very important that they get disposed of correctly, which is a whole interesting conversation that we discussed in environmental science about how that stuff gets disposed of. It's really dangerous. So, but anyway, I want to show you a video with an actual cathode ray tube. Are you ready? Yeah. We don't have one here at the high school, but at least not that you can like observe in a useful way. So I'm going to show it to you. And I have no idea why my internet is so terribly slow today. Like, look at how long it's taking to go into full screen. This is like the wire. This is not any Wi-Fi.
So today I'm at the University of Sydney with Dr. Louie, and we're talking about how our idea of the atom changed from tiny little parts here to something more complicated. And this apparatus has something to do with that.
Exactly. It was quite a landmark historical experiment. It's just made of a tube of glass connected to a vacuum pump, and in the tube of glass there are two bits of metal connected to high voltage power supply.
So we can suck the air out of here and apply high voltage to metal.
Yes. Normally, high voltage in air, we don't get anything except maybe a big spark. But what Geisler found in 1887 was something quite different. So should we have a look? Okay, let's turn on the pump and the high volts. Turn off the lights so we can see what's going on. As you can see, something's happening.
Yeah, I see a bit of a pink color in there.
That's right. So imagine Geisler was the first person to ever see this. It's pretty surprising. That started people thinking, what is this stuff that's coming from the cathode? It seemed to be a ray emitted from this negatively charged one, which they call cathode, therefore it's called cathode ray. And it became the topic for research for the next 40 years. All the big wigs of physics and science basically tried to work out what was going on.
So what did they figure out? I mean, what is going on? What's producing this load?
There were two main camps. One thought that it was waves, and the second thought that the electricity was being carried by a stream of charged particles. Over the next 40 years, they basically came to the conclusion, well, it was J.J. Thomson in 1897 who came up with the idea that there is a stream of very small charged particles, negatively charged, they're smaller than an atom. So the smallest atom, hydrogen atom, they're about 1,000th of the size of that. And it doesn't matter what material the metal is, it's always the same particle. So this particle appears to be everything. This electron, as it was known, is what's carrying the electricity.
So Thomson came to the conclusion that all atoms have this particle as one of their constituents.
That's right. So it wasn't a billiard ball, there had to be something inside a billiard ball.
So how do I picture like a billiard ball with bits inside?
Well, you should probably think about pudding. Yeah, well, that's what his idea was. There was a lump of pudding, very big, every British person's heart. That and inside the wing you have plums, and plums can come out of that. So when you apply high voltage and a negatively charged electron, which Thomson picture as a plum, comes out and leaves behind a positively charged wing.
Are you a fan of plum pudding?
For research purposes, definitely.
Alright, let's see if we can research this a little further.
Okay, that sounds like.
You guys kind of go through stuff fast. Does that make sense? Is that better to see or what? Is it better with the light on or off? All right. So basically, he had a tube, right? Glass tube. Suck all the air out of it using a vacuum. So that means that there is a vacuum inside there. There's nothing inside it except little metal thingies at the ends. Wire the thing up to a big fancy battery, essentially. Okay? And when you turn the battery on, or in that case, a battery, you'd have to have a heck of a big battery to get enough power. But definitely that thing boxes the numbers, you flip the switch on it. And you have something flowing from one end to the other. That's me trying to make an arrow, a dotted arrow. So a lot of scientists were trying to figure out what was going on here with this. Kate, are you with me? You should close your computer and be taking notes and watching what's going on here. So they were just trying to figure out what was this glow. When you turn the electricity on. So a lot of scientists trying to figure this out, and then finally J.J. Thomson was the guy that had the discovery that started to help everybody else make sense of everything. So he had this, I don't remember if he actually had literally a 3-point theory, but it works out pretty nice because I like the other guy 3 points. I think Dalton actually had 3 points, but anyway, I have 3 points for you. So he said that negative electrons move around within a solid positive sphere. Of course, you have to remember here that he was used to thinking about atoms in terms of the Dalton model, which was just the solid sphere, right? So his next idea was saying, well, let's just work with the framework of what is already making sense and has made sense for a very, very long time. And so, but now we have this idea of the negative electrons moving around inside there. So if you have negative electrons moving around in a solid positive sphere, that means that overall, it's what charge? What charge would the whole atom be if you have negative electrons in a positive sphere? What? I heard it. Neutral. Okay. He also said, and this is super important, that electrons are in everything. So he did some experiments changing what type of metal he put at the end of the tube, and he said, well, it does the same thing either way, whether I use iron or zinc or whatever. So the electrons are the same, all of them, and he did a variety of different experiments, experimenting with the specific behavior of them, and he didn't just simply only watch the glow. He did some other things with them too. but that was what he was doing. And he also said that atoms can become charged by gaining or losing electrons. So in other words, the electrons can jump out. And never before had they talked about this jumping out of an atom. Always before, an atom was just a solid sphere. Nothing jumped in, nothing came out. That was just a solid sphere. But now he's saying, no, the things can actually jump out.
Is that like static electricity?
It is static electricity, yes. Same idea. And so his name of his model was the plum pudding model. And he thought of it, okay? So like this is, you have to think of this as the solid sphere. But more importantly, it's a solid positive sphere. Because otherwise it would just be the same as this over here, right? So it's the positive solid sphere, but then inside it, there were negative chunks floating around. So like he thought of this as a plum pudding because that was a very common dessert in his day and age. You can think of it as like a chocolate chip cookie if you like. You know, the idea that you have like the solid cookie dough and then the chocolate chips are inside there, they're the negative part. However you kind of want to visualize that is okay. All right. And it was super important. Like the stuff that he did here is super important because today we still talk a lot about the loss, that's an S, or the gain of electrons. We'll talk a lot about that in our next unit. Electrons being lost or gained is very important, even still today. But what's not important is his exact structure. Okay? You want to see a video again?
Yeah.
So here's these same guys. Let's see, my video got lost because apparently I'm on autoplay. They're always changing how you have to turn autoplay off. Have you noticed that? This internet is really like off the charts bad today.
So the word atom means uncut.
That's right.
I just lost my page.
So we're thinking of it as a tiny hard sphere. That's right. And even up in
Question
the
with us?
1800s, that was the idea. And the smallest piece of matter, tiny hard sphere. Yep. So then we find out that that's not quite right.
Not quite. There are experiments in the 1800s that discovered the J.J. Thomson's experiments really worked out the electron was smaller than the 1,000 times smaller than the hydrogen atom.
And it was in all that.
That's right, not just hydrogen. Whatever material he did his experiments on, now
There are electrons in all that. So I guess when you find something that's smaller than an atom, you need to propose a new model for the atom that actually has some smaller and some substructure.
That's right. So something like this.
This is our model of the atom.
This is our model of it. He's able to know as the pudding model. here we have
cherry
cherry
tart.
tart. Okay. So, but the idea being that we have an overall pattern, usually which is spherical rather than 2D, but embedded within it is there are negative electrons represented by cherries, and they can come out. The overall pattern is neutral, so that means the quick part is positive.
Now, how do you get one of these electrons out of our equation?
So electrons are negatively charged, so we need to put something very positive which attracts a high voltage.
And then that would be the effect, say, like, plucking a cherry out of the pudding.
That's pretty much it. Yeah, you kind of like that.
So we're speculating what it would be like to put a positive charge on the
That's right.
pulling electrons down. Wow.
That's quite it. Yeah. So should we yeah. You want me to do it? Okay. Yeah, that's right. Ready? 1, 2, 3.
All right, so there you have it. Some things about J.J. Thomson's theory. Sound good?